Welcome back, everybody. We are ready for another set of notes. So go ahead and flip to Unit 3. We will be working on page 32 today. So 32. And the title of this page is going to be Absolute Value Transformations. So absolute value transformations. And once you get that written down, you'll need to tape that page onto page 32. So you were either given this set of notes in class or you might have had to print them off, whichever one. Just get them, fold them in half, and then tape them down onto page 32. And then when you get that done, push play. Okay, now that our notes are taped in, we're going to go ahead and start talking about transformations. So before we even begin with any of this, I want to kind of remind you about your middle school transformations. So those were called slide, flip, rotate. Those were your transformations that you did in middle school, and you did them to shapes. So for example, you would take this circle and shift it around on the graph, and you would call that a slide. Now what we're doing, transformations, we're still doing the same kind of transformations as far as the slide and flip go, but instead of moving a shape, we're actually moving this absolute value graph. So this V, we're gonna take it and move it around on the graph. So with that being said, so that's how it ties back into what you learned in middle school. I wanna talk to you about the parent function before we get started. So the parent function, this is the equation of the parent function. It's just absolute value of x. A couple lessons ago, I told you that the parent function is the easiest function of that function family. So again, if I were to grab all of the absolute value graphs in the world and put them all in the same spot, so all of the graphs that look like a V, this one would be the easiest one. This one was the original graph. Okay, so this one was our original, very first absolute value graph. All of the other ones that we see are just versions of this one. So with that being said, when we are identifying transformations, we need to compare the new graph, which is the one that you would be looking at, to the parent graph. So the parent graph is this one right here. It's the original. Okay. There are two things that we need to talk about the parent graph before we actually start identifying transformations. So the parent graph, here are a few things about it. The vertex is always going to be right here at the origin, which is 0, 0. So the vertex of our parent graph is always going to be 0, 0. And then we are also going to have a slope of 1, which, remember, our slope comes from the number in front of the absolute value, and that's an understood 1 right there. So that's why this graph goes up 1, right 1 on the right-hand side, and then it was just the mirror image to get the left-hand side. The graph always opens up. So those are just three things, which I didn't really write the slope part, but those are three things that always happen when we talk about the parent graph. Now let's just take a look at an example and kind of practice identifying what transformations have happened. So it says, what transformations have been performed on the parent graph shown below? So we have two graphs that have been graphed. One is the top one is the bottom one. That's how I'm going to refer to them, so the top and then the bottom. The first thing that we need to do is identify which one actually is our parent graph. So remember that our parent function, there are certain things about the parent function or the parent graph. The vertex is always at 0, 0. It always opens up, and the slope of the right side is 1. So first thing I notice is that vertex for the top one is at 0, 0, and the vertex for the bottom one is not. So that means that this top one right here is my parent graph. So I want you to write that. This is the parent graph. Now, I have right here that the parent vertex, so the vertex, remember, is the very middle point of our graph. That vertex is at 0, 0. Now let's talk about the new graph, which is the bottom one down here. I also want to put that as a little note. This is my new graph. It's the second one, so I'm trying to determine what transformations have happened to get this parent graph to the second one. So I need to talk about how am I going to move it around. And a good way we can do this is by using the vertexes of each one. So next thing, we're going to list out the new vertex. So the new vertex is at 2, negative 4. 2, negative 4. So those are the vertexes for both of them. So now let's talk about the transformation. So I want you to focus on the vertex. If I were to take this vertex and move this graph in some direction, what would I have to do to the graph to get it down here? There are two of them. The first one would be that we would need to move it right 2 units. Because if I move it right 2 units, then I'm right here. The next thing that I would need to do is I need to go down 4 units. So the transformations are right 2 units and then down 4 units. The slope is still that 1/1, so the width of the V didn't change at all. So these are the only 2 transformations that have occurred. Now, let's go back to the vertex and kind of see the relationship between the actual transformations and the vertex. We went from, remember, the first one that I listed was the X value, which is left and right. It was a positive 2, and that means that I'm going to go right 2 units. And the Y value went from 0 to negative 4. That shows me that I went down 4 units. So you can actually look at these vertexes and kind of predict what the transformation is going to be without even looking at the graph. Like if I gave you just these two, we could kind of talk about what happened to it. Okay? So that's just a very quick example on being able to identify transformations from a graph. Now, a lot of times we do not have the graph to look at and we're looking at equations. So when we get to the inside, it's going to be about equations. But if you're looking at a graph, it's just simply how do I move the graph to get to the new one, or what did I do to get to the new one? And that's it. Let's go ahead and move on. So now we are on the inside of our foldable on the left. Now on the left-hand side, I have put a chart. And I know it looks intimidating, but once I explain how these particular things move the graph, it's actually not that bad. But before we talk about this chart, I want to talk about this vertex form up here, because I put vertex form back at the top. And I want you to remember that vertex form is hanging up in my classroom on the back wall. That will be there. I will have to cover it up for the state test, but for my classroom test, you are more than welcome to use it because I'm not going to cover it up for my normal tests. So, vertex form, okay? It always is going to look like this. So every equation that you see, and we can kind of look at these examples down here, they're always going to be in this form. Now, granted, some of the letters are going to be missing. So for example, in this vertical translation, these first 2 examples, I don't see an A and I don't see an H, but I do see a K value because there's a number at the back. It's super important for you to study these letters and what they mean. So I'm going to show you which ones they are, and then you need to study the letter itself and what it means to the graph. Okay? So now let's take a look at that chart. There are 4 types of transformations that we can do to absolute value graphs. We've already talked about 2 of them, which was the horizontal shift and the vertical shift. We've actually already talked about 2 of them. I just didn't formally tell you them. So we are going to formally talk about all 4. Stick with me because once we start doing example problems, it all kind of meshes together. So the first transformation that we are going to talk about is called a vertical translation. Now, in middle school, this is what you would have called a slide. I don't necessarily use the word translation. I use the word shift a lot. So this is a vertical shift, which means I've taken the graph, which looks like this, remember, and I've shifted it in a certain direction. Now, the direction comes from the word vertical. The word vertical actually means up or down. So we are going to take this graph and move it up or down based on whatever sign and whatever number we're looking at. So the first thing that I want you to do, whenever we're looking at function notation, we have f of x and then this plus k. This plus k tells me my vertical shift. Okay? So I want to go up here before we even start these example problems. I want you to circle this plus k. This is our vertical shift. Vertical shift. We're going to label out what each of these letters mean. So whenever you're going to study for this test, you need to make sure that you know if a number is in that K spot, that is my vertical shift, which is going to be either up or down. Okay, so now let's talk about how you tell if it's going to be up or down. If there is a plus sign, so it's a plus some type of number, we're going to go up, whatever number that is. If it's a minus sign, that means that we are going to go down. Remember, the K value doesn't change signs, so whatever is there, that's how you move the graph. So that K value, which is the one at the back, it's on the outside at the end. It just tells you how the graph is being moved either up or down. You just look at the sign in front of the number to determine that. So in our two examples right here, how you tell whatever transformation is happening, you cover up the X, and then whatever number is still left, that means that that is a transformation. So for this first one, we have a plus 7. So that means that I'm going to move this graph up 7 units. And there we go. So I took the absolute value graph, which looks like this, and I just moved it up 7 spaces. That's all I did for that particular equation. Now take a look at the second one. If I do the trick where I cover up the X, because that's part of my parent function, this minus 4 is at the back. Now we need to talk about what that minus 4 does. Remember, if we see a minus sign, that means we're moving down. So I'm going to go down 4 units for this one. So that means that I took the absolute value graph, which originally looked like this, and I just moved it down 4 spaces. So that's what it would look like on the graph. If we were looking at a graph, we just took that absolute value and moved it up or down. I do want to tell you, I forgot to mention it, whenever we are talking about transformations, you need to tell me a couple of things. You need to tell me what direction, which is the up or down part, and then how many spaces, which is the number part. You can't just tell me up or down. You have to tell me up how many, okay? And that's it for vertical translations. Those are just the ones that you're going to shift up or down, okay? Now I want you to take a look at horizontal translation. So this is your other slide part. You called it a slide in middle school. It's now the official word for it is a translation, but keep in mind I use the word shift a lot. So we're taking the graph and we're shifting it in a direction. So vertical meant up or down. Horizontal is going to be right and left, okay? Think about the horizon. If you're looking at a horizon, it looks like this, which is right and left. So if I'm looking at my function notation, because we got to identify what letter it actually is, we have f of x and then that minus h. That h is your horizontal shift. So I want you to circle that h right there. And notice how it's on the inside of those brackets, which are parentheses, but it's on the inside. So whenever we go up here to look at vertex form, h is on the inside. H is always going to be on the inside, okay? So let's circle this h. And this is going to be my horizontal shift. So remember, horizontal, that's left and right. So this is my horizontal shift. Now, there is one weird thing that we have to do with my horizontal translations, and I'm going to put it over here underneath the words horizontal translations. We need to take the opposite sign of h. So take the opposite sign of H. So I'm going to write you just a quick little guide right here that tells you if you see a plus sign, how it's going to move. And then we'll actually talk about why we have to take the opposite. So if we see a plus sign, okay, if we see a plus sign, that means that we need to move that graph left. Now, I know it seems kind of counterintuitive because if we think plus sign, that means it's moving to the right. But here's the reason why we have to move to the left. So, the original equation for absolute value graph, vertex form, that minus sign right there is built into the equation. So if I'm going to take, like, let's say -2, because that was my H value, -2. And now I need to simplify this. This now becomes x plus 2. And so then this is what you would actually see, but in real life, this was your H value. It's just the fact that that negative was built into our equation already that changed the sign. So we need to change it back to the original so I can see the original number that was plugged in. So if you see a plus sign, we are undoing their simplification of the two negatives side by side because this was actually a left number, okay? I know it's kind of confusing, but that's why we have to change the signs. So if we see a minus sign, that means we're going to move to the right. And I'll try to explain that one too. So again, if I have this is already built into my equation, that minus sign is built in, and I've got a vertex of, let's say, 3, 5. This is my H value, so I'm going to plug in my H value. Well, now, you see how this number looks like a -3? Well, this minus sign was built into my equation, so I'm actually just looking at this +3, which is going to be moving to the right because it was positive. It was positive over here. We're going to do a lot more work with it, but really the thing that you have to remember is we have to take the opposite sign of H. And the reason is because this minus sign is built into your equation. Okay? So now let's take a look at these examples. Remember, horizontal is left and right, and it's opposite of whatever you think. So whenever you see these problems, you instinctively want to say something, remember it's going to be the opposite. So this right here, this is a -3. Remember that that minus is built into the equation, so I'm really dealing with a +3, which means I'm going to go right 3 units. So we see -3, we think left 3, but remember it's the opposite for this one. So we got to change the sign. So that's going to be a +3, which means I'm going to go right 3 units. Now this one down here, I'm going to cover, I forgot to do that. I'm going to cover up the X, and I've got this +2 on the inside with the X. That is going to be in that H value spot, and we got to do the opposite. So it's +2 right here. So that means it's actually -2. So I'm going to go left 2 units. And there we go. Those are your horizontal shifts. So remember, horizontal is left and right. Vertical is up and down. And when you are looking at equations and you are giving vertex form, you're given vertex form, these two numbers right here are always going to be your horizontal and vertical shifts. Now, it's lame, but I'm going to tell you how I remember which one's which. I actually remember the horizontal shift because H, that's what horizontal actually starts with. So the word horizontal starts with H. So I kind of tied those two together. So now when I do these kind of problems, I automatically know if it's on the inside where that H is, it's going to be my horizontal shift. So you can think about it like that, and that'll help you a lot. Okay? So now I have vertical stretcher compression is next. So I got to slide it down some. So stretcher compression is next. Before we talk about anything, problem-wise, let's talk about the function notation, that middle column. The letter that we are specifically talking about with stretcher compression is this A. Okay? It's going to be that A value. So up here in our vertex form, that A is always going to be the number out there in the front of the absolute value bars. So this is going to be my stretch or compression. So anytime you see a number out there in the very, very front, it's going to be a stretch or compression. Okay, now let's jump back down here. So, vertical stretch, okay? We need to talk about, so we have vertical stretch and a compression. One of them does something specific to the graph, the other one does the opposite. So, and it all has to do with the A value. So when we look over here, this 4 and this 1/2 does something specific to my graph. So we're going to kind of work through these. So vertical stretch. Let me show you, and I'm going to try to do it with a rubber band. Let me zoom out so hopefully you can see it a little bit better. And I'm going to be over here on this side. So a vertical stretch, because I want you to see what actually happens to an absolute value graph if we stretch it. So here's my absolute value graph right here. It's just a normal sized shaped V. Can you see it? There is my absolute value graph. If I stretch it, I want you to pay attention to the sides right here. Pay attention to what they actually do. If I stretch it, see how they got closer together so the slope got steeper? So here's my normal graph. And if I stretch it, I went straight up and I stretched it, my graph actually got skinnier or more narrow. That's what happens to an absolute value graph when you stretch it. So here's the normal. I stretch it, it gets skinnier. Okay? So, and that's what we're going to write right here. So a vertical stretch causes the graph to be skinnier. Okay? Now, the state is not going to use the word skinnier, so they are going to choose narrow. That's the word that they're going to use. So a graph that looks like that might look like this. It's just a skinnier absolute value graph. It's a skinnier V. Okay? Now, how we determine if this is actually what is happening goes back to that A value. So we're looking at that A value. If A is greater than 1, so A bigger than 1, it's going to be, so is a stretch. So A is greater than 1 is a stretch. So when we look at this first example right here, we're looking at, so again, if I want to do my little trick where I cover up the X, if I see a number, I have to deal with it and say what it does to my graph. So I covered up my X, and I've got this +4, or this +4. That is a whole number. It's bigger than 1, which means I'm going to stretch my graph. So what you would say, how you would describe this transformation would just be a stretch by a factor of 4. So stretch by a factor of 4. If you tell me that, then in my head, here's what's happening. If I see stretch by a factor of 4, I know that I took the normal sized graph, which looks like this, and I stretched it by a factor of 4, which caused the graph to be skinnier or more narrow. Okay? So that's what happens to a vertical stretch. You're just looking for that number that's in the A spot, and you're trying to determine, is it bigger than 1? If it is, it's going to be a stretch by that number. Okay, so a compression is the opposite of that. So let me show you. I'm going to do the best I can to show you this one. This one's a little bit harder to see. So I'm going to take my absolute value graph. You really got to pay attention on this one. So look over here at my little rubber bands. Remember that you are focusing on the sides of the V. So here's my normal sized V, my absolute value graph, my normal one. If I compress it, it means I'm smushing it together, okay? If I compress it, what happens to the width of my graph? So there's my normal one. If I compress it, did you see it? So here's the normal. If I compressed, you see how the sides of the graph actually get further apart? They get wider. So I'm going to show you again. Here's my normal graph. Sorry, this is my normal graph. And if I compress, see how the sides, they get wider as I go down and I'm compressing even more? That's what happens in a compression. So with a compression, the graph is actually going to be wider. And the state, there's not another word that says wider, so they're going to actually use the word wider. So a compression, the graph is going to be wider. So that's going to look something like this. It's going to open up more. Okay? And remember, I said it's the exact opposite of a stretch. So a stretch got skinnier, a compression got wider. Here's how we determine if it's a stretch. So remember, the compression is going to be the exact opposite. If A is less than 1, so that means a fraction or a decimal or just any number smaller than 1, that means it's going to be a compression. Is a, gotta write small. So if A is less than 1, then it is a compression. So A less than 1 is going to be a compression. So we have, I'm going to cover up that X, do my little trick. Any number that I see, I need to address. So the number that I see is this 1/2. 1/2 is smaller than 1, so that means it's going to be a compression, which means my graph is going to get wider. Okay? So how I would word this, it would just be compression by a factor of 1/2. So compression by a factor of 1/2. And there you go. Okay, so now we are on to our last one, which is very different from the one that we just did. I just told you that this one is the most challenging to freshmen because you didn't really do it in middle school. This one you did in middle school. This is the one that you called a flip. So you would take a shape and then flip it over the x-axis or maybe the y-axis, whichever one. You just flipped it, okay? This one is the same idea, except we don't call it a flip anymore. The mathematical word for that is a reflection, and that's what we call it. We call it a reflection. So this one, it is very easy to spot. So here's how you spot if the reflection's actually happening. If there is a negative, it's going to be out there in the very, very front. So it's going to be out there in front of the X, in front of everything. So I'm going to make a little note. So we got to come down here because that box isn't big enough. If there is a negative, and if is the important word, so underline that. If there's a negative, got a slight little typo here. Okay, if there's a negative, then it's a reflection. Okay, if there is a negative, then it is a reflection. If is the important underlined word there, because a lot of times you're not going to see a negative up there. And if there's not a negative, so like in all of these examples that we have already done, there was not a negative in the front. That means there was not a reflection. So that negative that you see has one job and one job only. And its job is to reflect the graph, to flip it upside down. So here's how you identify it. The negative is going to be out there in the very, very front. It's going to be the very first thing you see. If you see that, it's going to be a reflection, and that's all you would have to tell me. It's going to be a reflection. So here's the reflection and what it actually does. It takes the graph, which looks like this, and flips it upside down to look like this. That's all a reflection does. So I want to go back up here to vertex form. Here's my normal, I say normal vertex form. I want to add the negative sign, okay? And I want to do it right up here. So put a negative and then circle it. I want you to know that that negative is not always there, but if it is, if that negative is there, then it's going to be a reflection. But a lot of times it is not there. So it's on, like, if it's there, great, it's a reflection. If not, then you just keep moving on. So before we get into our practice problems that I've got over there, I want to talk to you about studying for the test. When you study for the test, you need to study this. You need to study vertex form, where these letters are in vertex form, and what they mean. So that way, on the test, if you see something that looks like this and there's a number put in for that H spot, you're going to automatically know, hey, that's a horizontal shift, so I'm moving left or right. That is the best way to study transformations. Study the vertex form, study the letters, study what the letters mean. So that way, when you look at problems like this, you're automatically going to know because you've studied where the letters go in vertex form. Okay, that is my one piece of advice when you're studying and trying to get ready for the transformation stuff. Just study vertex form. Then all the rest will come in. Okay, so now go over here to the right side. I have 3 different equations for us to practice, just listing out the transformations that have happened. And then down there, I've got to write the equation part. So we're going backwards. So let's take a look at the first set of 3. It says, describe the transformations that have occurred. We are going to work these backwards. So I'm going to do number 3 and 2 with you, and then you're going to do number 1. So number 3, take a look at number 3. Number 3 trips people up all of the time. So number 3, if I do the trick where I cover up the X, I need to circle and address everything else that is still there. Now, what trips people up on this one is they think that that negative goes with that 1/3. Remember that that negative has one job and one job only. So you need to circle them as 2 different things. So I'm going to trade. I'm going to keep covering up that X. This negative does something for me. This 1/3 does something for me. And so does this -4. All 3 of those things tell me something about the graph without even looking at it. My job is to, depending on where the number is, list out those transformations. So we're just going to go ahead and start. I have this one. The negative has one job and one job only, and that is a reflection. So I would just list out reflection. Boom, done with that one. So then I just keep on moving. This 1/3 that I see, I'm going to move it where you can see vertex form over there. That 1/3 is in front of the absolute value bar. So in front of the absolute value is that A value right there. So that's going to be a stretch or a compression. So I know it's either going to stretch or compress my graph. Now I need to focus on what the number actually is. So that is 1/3. That's a number smaller than 1, which means I'm going to have a compression. So compress by a factor of 1/3. Compressed by a factor of 1/3. That's what that 1/3 does to my graph. So instead of having a normal size graph, I'm going to have a slightly wider graph with this one. Oh, and I have flipped it upside down because of the reflection. Now, the only other one that's left is that -4, and it's on the inside of that absolute value, which is in the H spot. So since it's in the H spot, that's a horizontal shift, so that's either going to be left or right. And remember, you do the opposite of what this shows you. So this one is going to move right 4 units. And there you go. So 3 transformations have happened. We've listed out all 3, so now we are done. So I'm going to do number 2 with you, and then I want you to do number 1. So number two also trips a bunch of people up, because I want to practice hard problems with you that normally get you, so that way you don't miss it on the test. So number 2, let's take a look. Let's do our little trick where we cover up the X. Any numbers that we see we need to deal with. I see 2 of them. I see this 4/3 out here in front, and then I see this +2 back here at the back. And that's the only things that we need to address. So again, it's all about the position. So what letter are these numbers sitting in? So this 4/3 is in front of the absolute value, which means we are in that A spot. So this is going to be a stretch or compression. Now, normally, if we're in class, I've got some kids screaming, "Oh, it's a compression," because they see a fraction. But this right here is an improper fraction, which means this number is actually bigger than 1. So be careful. Be super, super careful. Just because you see a fraction does not mean that it's a compression. So this one is going to be stretch by a factor of 4/3. So be super careful. Pay attention to what the fraction is. Make sure that if it's improper, that you label it as a stretch, because that's a number bigger than 1. Okay, we're not quite done because I haven't done anything with this +2 back here. So that +2 is it's at the back behind the absolute value, so it's in the K spot. That K is a vertical shift, so I'm talking about either up or down. This one, since it's a +2, we're just going to move up 2 units. And there we go. So what I want you to do now, take you, I don't know, like a minute or so, work on number 1. If you need help, look at 2 and 3 as a guide, and look over here at vertex form, because that kind of shows you if the number is in a certain position, how it affects the graph. And then if you need specifics, then look back down here at the chart on how it actually moves it. So go ahead and pause this video, get number 1 done, and then push play when you're done. Here is number 1 for you guys. So again, I just covered up the X, and then I circled all of the other things that were there, so that way it would be easy for me to spot and then talk about what they actually do to my graph. So that negative, reflection. Remember, negative has one job and one job only. Reflection, done with it. Move on. This +2 is in the H spot, so it's going to be left or right, and we do the opposite of what that one says, so it's going to go left 2 units. This one back here at the back is our vertical, so that's either up or down, and that one just does whatever the sign says. So this one is down 6 units. So I hope that makes a little bit more sense. Please study the letters, the position of them in vertex form, and then what they actually mean. Okay? What we're going to do now is talk about going backwards. So here's what I mean. In these first 3, we were given the equation and we had to describe what transformations happened. Down here, we're doing the opposite of that. So it says write an absolute value equation given the transformations that have occurred. So this time we are given the stuff that we would normally write, and we're asked to come up with the equation instead. So I'm going to show you, let's do number 2. Because that one's probably the quote-unquote hardest, and I always want to do the hardest ones with you, and so you have the right kind of guide for you to do the other ones. So here's how I do it, and here's what happens in my brain. I always read it, so reflected, that means it's a reflection, so that one is going to have a negative in the front. So in my head, I would just make a little note like, hey, that's going to be a negative. Compressed by a factor of 1/3. Well, stretch or compression, if we look back, is the A spot of my equation. So I would just make a mental note of that. I would write in my head or even on my paper that that's going to be my A spot. And then I've got 4 units up. Well, if I go up here, up is a vertical direction, so that's going to be in the K spot. So I would just make a note of that. That's going to be my K value. And that's how I process this. So now I would just need to build my equation, and it's going to look like a vertex form up here, except if you're not plugging in anything, you just don't have to worry about it. So let me show you what I mean. All equations are going to start off with f of x. They always do. And remember, so I'm going to try to zoom out so that way I can show you vertex form up at the top. There we go. Perfect. Okay, so I have f of x, which is up here. That's how they start. I have something that has been reflected. So the reflection, that negative is going to be at the very, very front. The next thing I have is compressed by a factor of 1/3. That's my a value, so that's the next thing I see. So I'm going to have 1/3. Then I've got absolute value bars, so I'm going to put absolute value of x. Now, before I just automatically keep writing, I want to check to see if I have an h value. If I don't, then I can close my absolute value bar. I've got a k, but not an h. So I'm going to close that. And then I've got 4 units up. So that's going to be at the back because that's my k value. So 4 units up is just going to be shown by +4. And there we go. So if you want to, you could double check and take your equation and kind of run through. So like this one is a reflection. That would be compressed by a factor of 1/3, and that would tell me 4 units up. You can kind of double check just to make sure that you actually created the correct equation. Okay. I want to also do number 1 with you, because we didn't do a horizontal one right there, so I want to show you how those actually work. So there's vertex form up there at the top. Now remember, when we read this, we are identifying what letters we're going to be substituting in for. So shifted 3 units right, so that's a horizontal shift. So that's going to be my h value. This is going to be my k value because it says 5 units down. So then I look up here at vertex form. I know I'm going to have f of x is equal to, I'm actually not going to have a negative or an a value because it didn't mention either one of those. So I'm going to automatically start with my absolute value of x. And here's my 3 units right. Now remember, this is opposite. So if I actually went 3 units right, in my equation, I'm going to see a -3 because we do the opposite of what is shown in there. So that took care of my h value. Next would be my k value, which that's just 5 units down, so that's going to be a -5. So be careful whenever you have the horizontal shifts, because those are the ones that trick people up, and sometimes kids get them wrong because they forget to flip the sign. So go ahead and do number 3 for me, and then push play when you're done. And here is number 3 as promised. So again, I just labeled out what they actually would be, like what position I would plug them in vertex form. And so here's what they look like if I plug them in. The one that I really want to talk about is the h value, because that's the opposite one. So if we go 2 units left, then it was actually +2 in my equation. So just make sure that you take your time if you ever have to deal with the h value. Just take your time. Okay? So I just want a quick recap before we end this video. There are 4 different transformations, and here they are. The first 2 are pretty straightforward. We're either going to move up, down, left, and right. The weird thing about horizontal is you have to do the opposite of that. This third one right here, the stretcher compression, is the one that freshmen typically struggle with the most. Really anybody. When they first see it, this is the one that they struggle with the most because it's the newest one, and it's one that you didn't do in middle school. So we're going to take a lot of time to practice that one. So if you're still a little bit confused, that's okay. We're going to keep working at it and get better, because it takes practice in order to get better at stuff. And then the last one is reflection, which is pretty straightforward. It's either there or it's not. So just like I said a couple seconds ago, if we are still a little bit confused and we mess up a little bit here and there, that is okay. We're human. We are going to get better at this. So good job today, and I will see you in the next video.